The heart was made to be broken. Oscar Wilde. Heart failure is a condition when one's heart is unable to pump blood around the body properly. Heart failure is a major and growing public health issue, afflicting more than 23 million individuals worldwide.
Although over the past few decades we have been observing advances in treatment of cardiovascular disease, the incidence of heart failure in patients and associated mortality rates have improved only marginally. The myocardial scar formation, known as cardiac fibrosis, is a key contributor to heart failure. Cardiac fibrosis starts with the death of cardiac muscle cells after injury or due to disease. This results in an inflammatory response and triggers changes in the mechanical and structural properties of heart tissue. In consequence, it leads to activation of cardiac fibroblasts and their transdifferentiation into myofibroblasts. Since scar formation has been shown to be reversible, targeting fibrotic tissue has been proposed as a part of the treatment. However, antifibrotic therapies are still under development due to limited understanding of the molecular processes behind scar formation. I'm Aldona and I'm Marie Curie postdoctoral fellow in the Eurotech program at DTU in Denmark. In my research, I seek for better understanding of the scar formation process.
In her studies, Aldona is trying to recreate cardiac fibrosis on a dish by using mechanical stimuli, like surface stiffness to activate fibroblasts. She aims to understand how mechanical stimulation triggers intracellular signaling networks that control cardiac fibroblast plasticity. Free radicals, a class of reactive molecules with a free electron, appear to be crucial for this process. Despite undeniable importance, relatively little is known about their role in regulation of cardiac fibrosis. A main reason is that free radicals are short-lived and difficult to detect.
State-of-the-art methods cannot be successfully applied to investigate the role of free radicals in cardiac fibroblast plasticity. This is why I've been developing nanodiamond-based quantum sensing technology to detect free radical generation in real time in single cells with nanoscale resolution and from selected cell compartments. This technique allows to read out a magnetic resonance signal optically and therefore combines the advantages of standard MRI and fluorescence imaging.
Aldona is working on the quantum sensing technique that relies on nitrogen vacancy centers, which are defects in the structure of nanodiamond. The sender has a spin state that can be read out optically, as its fluorescence intensity depends on the surrounding magnetic field. The free radicals affect the spin state of the center, with intensity changes of the emitted fluorescence as a result.
Aldona will shed light on the heart scarring process using quantum sensing technology. Her work aims to establish quantum sensing protocols for drug screening in cardiac fibrosis, far beyond it. It always seems impossible until it's done. Nelson Mandela.